Now that you've chosen a little bit about vector data or raster data in our neck of the woods, let's dig into vector data a little bit more. There's our real world up there. We got a lovely house and our river and our trees. In raster data, we're aligning those features to the grid there. You see that we have a house cell, we have a river, some river cells, some pine cells, some spruce cells. I assume that because it's P and S in their trees. We're limited to how the data can fit into the structure available. Whereas for vector data, we can do a much more linked. We can draw those areas much more clearly. We can represent things as points or lines or polygons. So we have a little bit more flexibility. The core difference really is that vector data allows you to build elements and topology in your data set. And raster data is pixels arranged in a grid. Both have long been used for GIS work and will continue to be. And we've progressed far from early GIS where you could only use one type or the other. Now we can use them both. So the distinction about the structures is still very important, but maybe we're not as limited as in early GIS work with picking one lane or the other. We can do both. Here's some more vector data. We see our roads, we see buildings. Some of our buildings are purple and some are blue. Don't know what that's about, but that's cool. We have elevation lines. Vector data has a precise shape. We can get the details. We can show the detailed differences. It has precise position. We can map a vector point as well as we have the accurate location for it. If you're staring at this and have ever done any CAD or computer-aided design, yep. In the same universe, that's for sure. Each of our points, each of our lines, each of our polygons, each of our features can have detailed attributes and metadata, and then be displayed or calculated on or worked with based on that attribute information. So vector data is very robust in terms of what it can do. Here's some vector data, some points, lines, and polygons. It's kind of stark, but I think I get the idea of this map. Red lines for our town boundaries. The black lines are some kind of road network, but there's also some rivers in here, so some networks. Got some little buildings with a flag, which I think are schools. So we got points, lines, and polygons living in there. Points are locations. So in this case, we could have schools, location of schools. Here's the XY coordinates. XY means that we have an X coordinate and a Y coordinate. We put those coordinates together, connect it with some kind of coordinate system. Pretty cool. And then we can plot it on the planet. These points represent specific geographic locations and then have attributes depending on what's in there. So we can imagine for a schools file, some attributes that might be useful might be school name, address, school level, maybe the mascot. Go Pandas. Past point, we have lines. Lines are a segment or arc with specific geographic location. Again, lines have specific values depending on what's in their attribute table, and they have both direction and length. Now you might be thinking, well, how do I create a line? Well, you start at point A and then you go to point B and then you have a line. And if that is the same line, say it's the same road, it's Main Street. Well, Main Street might be point A to point B and point B to point C and so on and so on. Get the idea. Line characteristics give us give us networks. As we build all of our lines, we then have networks. Our networks then allow us to understand flow and movement, all those kind of things. Some lines flow in a certain direction, rivers, one way. Some lines flow in multi directions, like a road. Arc. We have a video later on about talking about arcs. Then we get a polygon. Point line polygon. Enclosed areas with a specific geographic location has a shape. And really, so let's imagine our lines. If you have a line that runs from point A to point B, and then from point B to point C, and then point C to point A again, you have a triangle, which is a shape, which is a polygon. Each of our polygons has attributes. Put whatever you want to in there. Towns, town name, town population, town area. Look at all those attributes we could think of. We can build up these attribute tables with whatever information we want to put in them. But at the end of the day, a polygon is just a bunch of lines, and lines just 2 points. So they all come kind of circling back to each other. There's the, I keep saying attribute table. Here's an attribute table. Vector files all have one of these. The things that are within every one are the FID, the FID, feature identification. Every single feature, in this case, we're looking at states. I can tell because there's a column or a field that says state name. Every individual polygon has its own FID so that we can reference it and keep it organized. And then everywhere, every attribute table is going to have some kind of shape information. In this case, these are polygons because our polygons are shapes. I mean, our states are polygons. Actually, no, that works too. Polygon is our shape. Why are they polygons? Because they are states. And states have areas. We can select things out of the attribute table based on their attributes. And we will practice that in lab 3 extensively. So if I want to select states with certain characteristics, in this case, it looks like I'm selecting states with low population. I can do that. I can run a query. I can order and organize this table alphabetically or by numerical value. I can run selections. I can perform analysis. All of this looks like a spreadsheet, right? This looks like a really exciting Excel spreadsheet. But inside of GIS, we take advantage of the spatial connection, and we can do other types of selections. We could select things that are next to each other or adjacent, or we could select things within a certain disk. All this other stuff we couldn't do without the GIS. But thinking of an attribute table as a database, as a spreadsheet, I wouldn't say it's wrong. Can't select by location in Excel, though. Show me the dots near the other dots. Cool, dots. Now, we can go a little bit more in depth about the advantages and disadvantages of vector data. Vector data looks the same at any scale. So there's our dots. You zoom in. The raster image eventually gets to pixel level. It's all kind of blurry and stuff. But the vector points look the exact same. Again, it's easy to change the coordinate system. Look, there's the, what would you call that? Inner Mountain West. There it is tilted. We can change our coordinate system without any trouble at all. We will practice that later on in the labs. And of course, it looks good on a map. Look at that beautiful map of the Bay of Fundy down there. Vector data allows us to make those lines, to make those connections, to display things like that. If you're a graphic design person, scalable vector graphics, SVG, there's vectors everywhere. Some other things to emphasize: it's really easy to reference hard copy maps with vector data because they are often shared in the same kind of creation. If you remember Roger Tomlinson, digitizing those maps, turning maps into digital lines, there it is. Linear features, mentioned that, roads, river boundaries, all very good. And it can follow those features very closely. We can create vector data and have very precise XY coordinates, or we can take very precise XY coordinates and then create vector data from that. That's Lab 5. See how much fun we can have in GIS? Now, some disadvantages. Vector is not perfect. None of these data formats are. I don't want to pretend that they are perfect data formats because they are all abstractions at the end of the day. Remember, GIS is all about abstracting the real world into digital form. Detailed shapefiles can be very difficult to load. ArcPro can handle millions of features in an individual shapefile. That takes time to load and manipulate and analyze. Certainly takes a long time. Would raster be any better? Maybe, maybe not. But vector data will let you do it, so you kind of have to wait for it. Vector data also has issues with spatial continuity because vector data is shapes made up of points, lines, and polygons again. You can get these issues with slivers, where our shapes all don't align perfectly. They become non-continuous. This is not Middle Earth. We do not just have gaps in our planet for elves to escape to. Our planet's surface is continuous. So our vector data can at times, if we're not, say our positional measurements are inaccurate, say we were just digitizing from a map wrong, any of those things can create gaps. Well, we can fix those, obviously. But that comes down to kind of the topology, there's that word again, topology, of the layers. Our shapes, our vectors have to have consistent and complete shapeage. Some math PhD somewhere shuddered hearing me call topology shapeage. But the shapeage has to work for our relationships to work. And with vector data, especially, and obviously with spatial vector data, you have to be in GIS to make those changes. Raster data can be edited, sometimes in just text editors, better or worse. Makes it a little bit easier to take it to other programs sometimes. Vector data, sure, there's plenty of Python tools, and R can use vector data or shapefile in some ways too, but when it comes down to it, if you need to fix your boundaries, if you need to fix your shapes, if you need to digitize, you have to hop into GIS to do it, for better or worse. So we can pretend, we're doing a little analysis right now. Pretend that we are doing some of this GIS work. Here's Framingham. We've got this green is open space, and we've got our little red triangles as hazardous material sites. If we wanted to build a school in Framingham, but we wanted to make sure that we were not within the open space and not within 500 meters of hazardous material sites, well, with vector data, we can just create that data. We can make it, we can do it. We can run a buffer tool and say, hey, measure 500 meters from this site and show me where that is. And there they are. Lots of different rings, lots of different buffers. Again, when we think about the attributes in this information, when we think about how they're structured, a spreadsheet can't do this. We might have the names of the hazardous material sites, we might have their addresses, but we require spatial functionality to be able to understand the relationships between our features and other features, or between our features and things that we want to know and understand from them. From there, we could say, okay, show me the areas, show me the spaces that are not in the open space or in the hazmat buffer. And we can declare maybe these are our safe spots to build a school. There could be a lot more that goes into this. But from this set of analysis, we can pick here. And that's because all of these features, the points, the polygons, the lines, everything has a shape and has a relatable topology that allows us to connect and work with this data spatially. It gives us not only the overlap or the connection between their components, but also allows us to merge and analyze and adjust them. This is just a short list of some of the things you can do with vector data. Vector data is a lot of fun. We can have a lot of fun with it. Clip, erase, both two things that are going to be big for us in future labs. But for now, take a little break. Find the next video and we'll finally start talking about that topology word I keep using. The math people don't chase me down.